Hello and welcome to Math Easy. In this video, we'll be solving logarithmic equations. I'll be showing you the relationship between logarithm and indices with two examples. So we have our first example here. It says log to the base of 2 of 3x minus 1 equals 5. So the general form of a logarithmic equation is when you have log to the base of a of b is equal to c. All right, so with this now we can assume that a is equal to 2, that is the base, and b is equal to these terms in the bracket, which is equal to 3x minus 1, and c is equal to 5. So when solving logarithmic equation, it's very important to understand the relationship between indices and logarithm. So this logarithmic equation now can also be written in its exponential form to be equal to this b here, to be equal to the base a to the power of this c. So this is the exponential form of this. Now, if we want to rewrite this in the form or in its exponent form, we are going to have b as 3x minus 1, right? So we have 3x minus 1 is equal to a, which is 2, to the power of c, which is 5, right? So this gives us 3x minus 1 is equal to 2 to the power of 5. It's same as 2 multiplying itself 5 times, and that will give us 32. So the next thing we want to do here is to add 1 to both sides of the equation. If we do that, we're going to have 3x is equal to 32 plus 1. This gives us 3x is equal to 33. To find x, we are going to divide both sides of this equation by 3, right? So this we cancel out to give us x is equal to 3. We go into 33 11 times. So the value of x in this equation equals 11. So the right option here is option D. And we have a second example here. I want you to observe this quickly and comment if you notice any difference between this example and the first one we solved. All right, as usual, we have the general form of a logarithmic equation to be equal to log to the base of a of b is equal to c, and this exponential form is equal to b is equal to a to the power of c. In this logarithmic equation now, a is equal to x, b is equal to 27 over 8, and c is equal to 6, using the properties of logarithm. So the properties of logarithm we are going to use that says if we have, for instance, n log to the base of a of b, that this is equal to log to the base of a of b to the power of n. So we have just brought this n to become the power of b. So if we rewrite this logarithm, it's going to become log to the base of x of 27 over 8 all squared is equal to 6. So now that we have this, we can then write it in its exponential form to be equal to, so b now is 27 over 8 all raised to the power of 2. So we are going to have 27 over 8 all squared is equal to a, which is x, all raised to the power of 6. I hope you understand what I've done here. Now that we have it in its exponential form, and if you notice, the unknown is the base. So what we want to do now is to find a way that the powers are equal so that we can also equate the bases. So the first thing we want to do is to see how we can break this down. Remember that 27 is same as 3 times 3 times 3, which equals 27. So instead of writing 27 here, let's write 3 to the power of 3 all over 8 is same as 2 cubed, right? 2 times 2 times 2. So we have 2 to the power of 3. Then all squared is equal to x to the power of 6. Okay, remember one of the properties of exponents which says if you have a to the power of 3 all over b to the power of 3, so that this can become a over b all raised to the power of 3. This power is shared between a and b. Another property of indices says that if you have a to the power of 3, power of 2, we have the rule which says power of power rule by multiplying the powers to have a to the power of 3 times 2, which gives you a to the power of 6. So we are going to apply that property here by using these powers to multiply the power. If we do that, we're going to have, this is going to become 3 all over 2 all raised to the power of 3 multiplying 2 is equal to x to the power of 6. I hope you understand what I've done here. I've brought out these common powers outside and I used it to multiply this power. So that's why we have 3 over. This 3 times 2, 3 and 2 is affecting both the denominator, the numerator and the denominator of these terms inside the bracket. So this is going to give us 3 all over 2 raised to the power of 6 is equal to x to the power of 6. So now we have same powers, equal powers. So therefore, the bases are also equal. In that case, the value of x is equal to 3 all over 2. And this is our answer. So the right option here is option C. If you find this helpful, please do not forget to leave me a comment, like this video, share, and please support me by subscribing to my channel. Bye bye.